Hello, everyone, and welcome to today's SANS webcast, Lessons from a Real-World Living Off the Cloud Attack, sponsored by GEM Security. My name is Mary Lynn Gollier of SANS. Today's featured speakers are Phil Naray, VP of Cyber Defense Strategy at GEM Security, and Yotam Mehtar, Director of Cloud Response at GEM Security. If during the webcast you have any questions for our presenters, please enter them into the Q&A window at any time. Please note that this webcast is being recorded, and a copy of the slides and recording of this webcast will be available for viewing later today and can be found on the SANS registration page. And with that, I'd like to hand the webcast over to our presenters.
Thank you, Mary Lynn. Hi, I'm Phil, and I'm here with Yotam, who's going to be doing most of this presentation. This must have struck a nerve as an interesting topic because we have over 600 registrations for the webinar today. Yotam is perfectly suited to talk about this topic. He has over 10 years of cybersecurity experience, and before being part of GEM, he was at Signia, which is a global cyber consulting and incident response firm, where he addressed some of the most sophisticated cloud attacks that we've ever seen. He's going to be giving an anatomy of a real-world multi-cloud attack. And then I'm going to be wrapping up at the end with a brief overview of GEM and our cloud detection and response solution. So over to you, Yotam.
Thanks, Phil. So with that, as Phil said, we'll jump straight into our first section here, which is a deep dive into a sophisticated multi-cloud attack that we've seen. I should just say a quick disclaimer here, because we are very sensitive to the confidentiality of our clients. I'm not going to reveal anything about the identity of the client that I'm talking about here. And also, I should mention that we've modified certain details combined from different attacks that we've seen in order to protect that confidentiality. However, it's important to note, everything that we'll be discussing here is real attacks that we have seen in the wild. And therefore, we think they're important as lessons we can all learn as far as how to defend cloud environments. So with that, I'll jump straight in with a quick overview of who these attackers are, the ones we're talking about here, and unfortunately, a type of attacker that's growing ever more prevalent in the cloud. So the attack group we're talking about here has essentially specialized in cloud environments by doing a few things which all rely on the unique characteristics of these cloud environments. So these attackers are performing automated scanning at a very wide scale on a continuous basis, looking for initial points of entry across cloud environments. So they're looking for things like misconfigured S3 buckets or other storage buckets online that they can access. They're looking for things like code or databases or even compute resources, which have been misconfigured in a way which could allow either direct access, unauthenticated access, or authenticated access, but in a way which could easily be brute forced from the internet. So they're running these kinds of scans all the time, looking for potential victims. And whenever they get hits, this is all automated, right? So they get these big piles of hits, and every morning attackers can come in and say, okay, these are our new potential targets. We now have an initial compromise of maybe 100, maybe 1,000, who knows how many environments every day. And now we can use that in order to target these environments and start performing the attack. So even this first step, which when looking at on-prem environments, of course, there was scanning, of course, there was automated things, but nothing like this. So the scale at which we're seeing attackers leveraging the similarity of different cloud environments, I apologize, and to perform these automated attacks and get into many environments is extremely wide and extremely effective. So this is just some context into the kind of group that we're talking about here. This is one of the largest groups performing these kinds of attacks. And with that, we'll jump into the specifics. So the attack, as far as our client is concerned here, the victim of this specific attack, began with a specific, very common, unfortunately, mistake by a company employee. So one developer working for this company committed code to GitHub. This is something this employee would do many times a day. This is a part of standard procedure. But unfortunately, in this case, by accident, a piece of code containing hard-coded credentials to a cloud environment was accidentally committed to a public-facing GitHub repository. So this employee didn't mean to put that in a public repository, but they did accidentally. What did happen in this case is the employee very quickly realized their mistake. So it's not like this was committed and nobody knew. The employee realized something was wrong. And very quickly, they followed up by removing this specific piece of code. So the key was removed from the latest version in the GitHub repository. And this employee had assumed that because they really reacted quickly, this was a question of a few minutes, the problem was solved. Now, unfortunately, this isn't wholly true. So as I mentioned before, these attackers that perform these scans, they know what they're doing. They do this in a very effective way. And the scanning is continuous and ongoing, and it's not that superficial. So unfortunately, what happened here is that attackers, while scanning and cloning this repository, which, as I said, this was a public repository, so anybody could have and was allowed to clone this repository, they were also able to see multiple versions of history for this repository. So despite the fact that the key was removed by the developer, this didn't really get in the way of the attackers performing their continuous scanning of getting these specific keys. This is actually a snippet from a real piece of code that was targeted here. Of course, we've blacked out the credentials themselves, but as you can see, this contained specific credentials, in this case for an Azure environment, which was owned by the client, a production Azure environment, and the attacker now had these credentials at hand. So if you look at the bottom of the screen here, we're essentially running through the different phases of the attack, but the reconnaissance, the initial external reconnaissance performed by the attacker here to get their initial foothold in the environment was really very simple. It was automated. They were probably targeting many, many organizations this way. They just happened to get lucky with this one. So this initial mistake is what triggered the attack. But once attackers had these credentials at hand, of course, they had to figure out how they move forward, how they actually use these credentials to target and effectively monetize their access. So to do this, attackers started performing their initial access by compromising Azure. Now, I should mention one thing about the way the attackers compromised Azure here, because it is something that we should learn from, because a lot of attackers have gone on to doing it this way. So if the attackers would have taken these credentials and then, let's say, just used a standard anonymizing VPN or their own IP address to access the Azure environment, it's not a guarantee, but it's very possible this activity would have been detected fast, because a lot of organizations have either generic or tailored monitoring to detect exactly this kind of behavior, especially with privileged application credentials, which shouldn't be coming from just anywhere. However, attackers are onto this. They know that a lot of defenses look for this kind of behavior. So what they do here is, instead of going straight to the Azure environment, they do really a little bit of work to gain some detection evasion. And the way they do this is, from their own environment, they do go through an anonymizing VPN. That's the first step they take. But from that VPN, they don't go straight into the victim, the target Azure environment. Instead, they go into another compromised Azure environment, one that they've compromised before. So essentially, they're using resources, sometimes compute resources, sometimes just default proxies within different cloud environments, but they use resources, in this case, in another Azure environment, in order to tunnel their communication straight to the client environment. So essentially what we're seeing here, if we're the client, and you can see a little snippet from the logs here, this is the way this login with these credentials would appear on the client side. So we're seeing that the source IP address, the source from where this authentication is coming from, is actually just another Azure IP address. It's a legitimate IP address owned by Microsoft, by Azure. Now, obviously, a lot of people can do a lot of things with Azure, both legitimate and illegitimate, but because the connection is coming in through Azure, the likelihood of an immediate alert is going way down. And this is what happened for this organization. There was no alert for this initial access, because Azure IP addresses are authenticating and performing operations in the environment all the time. So by doing this very simple tweak, going from a VPN to a different Azure environment, and from there to a victim environment, attackers really gain a lot of wiggle room as far as evading detection. Now, once they have this initial access, attackers started looking around, figuring out what's going on, where did they actually land. This part, of course, they're not sure about yet. And luckily for the organization, initially, disappointingly for the attackers, they discovered that this specific Azure environment isn't very interesting from a monetization or data theft perspective. So this Azure environment didn't contain sensitive client data. It didn't contain financial systems which could be manipulated. And therefore, it didn't immediately lend itself to monetization for these attackers. However, this environment also had different things the attackers couldn't see initially because they didn't have full global admin privileges when they just got into the environment. However, attackers were able very quickly here to escalate their initial application credentials, the ones that were compromised, into a comprehensive global admin off this Azure environment. And the reason they were able to do this, we're not going to get into every technical detail of the configuration, but it had to do with the fact that this application, because it was just an application configured to do its own role, it was actually enabled. Nobody prevented this from happening within the organization. It was actually enabled for assuming other powerful roles in the environment. So the escalation of privileges from just being able to run what this application can do to full administrator was quite quick. Attackers were able to go from having their own relatively low privileged roles assigned to them to a full global administrator. Again, we're blacking out the users here and we don't want to reveal the specifics, but this is what attackers essentially wound up with. Now, once attackers had these more powerful credentials in the Azure environment, they did identify something very valuable to them, and that is federated access to AWS. So even though this Azure environment in itself did not contain the organization's most valuable or sensitive credentials, what it did contain was federated access. So essentially, Azure was being used as an identity provider, as many organizations do, Azure AD, for a separate AWS environment, which before identifying this, attackers may not have been aware of at all. But now that they're aware of this stage, they can continue along their attack. So they have their privilege escalation within Azure. Now they can perform cross-cloud lateral movement. And this cross-cloud lateral movement is key, not only because of what we're about to see in this attack, but also because many organizations struggle with fighting back against this specific strain of lateral movement. So unlike a lot of lateral movement that we see that we're used to in an on-prem environment where people move between servers or workstations, they're all in the same Active Directory, cross-cloud lateral movement could be more difficult because different cloud environments may not have shared management. However, when it is achieved through things like this, like federated access, which enable valid sessions to be created from one cloud environment to another, this often creates another big hole in an organization's ability to detect this behavior, because the federated access, again, is the way that people should be accessing the AWS environment for our victim, for our client here. And therefore, the very fact that a connection is coming in is likely to be missed by a lot of detections and by the SOC. So once attackers perform this jump over from the Azure environment to AWS, that's when they realize that they truly hit the jackpot. So this environment was the key core production environment for this client. There was a lot of very sensitive client data. Again, we're not going to refer specifically to the kinds of data as to not to reveal the identity of the client, but most of the company's operations were centered in this AWS environment, and that included key data, both business data and customer data, stored in S3 buckets, in RDS instances, and in compute resources, as well as secrets manager secrets. This is an AWS service used to store application credentials, sensitive credentials, which were all in that environment. So right away, when looking into this attack, we see that attackers moved very quickly, targeting these three areas: S3 buckets, databases, and secrets manager secrets. And the reason is obvious. So attackers know, because a lot of these cloud environments are similar, they know these are the things that organizations use to store potentially sensitive information. So the attackers didn't know in advance exactly which information would be the most sensitive and what they should be targeting, but they didn't know which services they should be targeting. And because they already had a privileged session within AWS, they just very quickly moved to get as much data as possible out of all of these. They can later analyze it offline. I'm sure most of the data they got wasn't interesting at all to them, but it doesn't matter. Once they did hit the client databases, once they did hit critical privileged credentials, the headache for the organization in recovering from this is, of course, much, much larger. Now, different attacks go in different directions. In this attack, the attackers were very intent on monetization. This was not a long-term espionage effort. And therefore, the next step that they took was something which is actually less common in the cloud. We have seen it in a few cases, but it's unfortunately becoming more and more common, but is still not as common as it is for on-prem environment. And that is not just taking data, but actually performing encryption of data and disrupting service. So once they had all their relevant data out, attackers moved to remove backups and previous versions of key resources within the environment so they can't be easily recovered. Stuff like S3 versioning and database backups, these were deleted or removed from the environment. And then attackers access the specific data in different services, including compute resources and hard drive resources and S3 buckets and databases, and encrypted the data that remained. So first step was ensuring that it's not that easy to recover this data, because a lot of it was removed through configurations. And then the data that was still there was encrypted. Now, this is effectively very similar to what we see in ransomware attacks against on-prem environments, where this is standard procedure. In the cloud, it's becoming common. It's not as common yet for a variety of reasons, but I will say the choice of encrypting data is not the only choice. It's what attackers chose to do here, but of course they could have just deleted the data as long as they kept copies and then asked for payment to give it back. And there's different ways they could have approached this. However, here, this is the way they chose to do it. So classic encryption after getting rid of a lot of the backups that could have solved the problem for the organization. And unfortunately, this was the first point throughout this whole attack where alerts started going off for the organization. So this is when the organization found out that something is deeply wrong, that an attack is going on. Obviously, the services were down. And as they started investigating, they started figuring out everything that I just told you, this whole complicated story about how attackers got in, the different stages of the attack, and how they were able to get to such a devastating state. Now, instead of focusing on what came next, the incident response efforts, the negotiation efforts, a lot of efforts which did, of course, happen and are valuable and important for responding after being put in such a situation, what we want to focus on today instead, and I think is very important for as a learning opportunity from this kind of attack, is instead of what happened after we got here, let's go back, let's analyze how we even got to this step and how we could have avoided it. Because once an organization is here, regardless of how good the incident response effort is, this is not a good position to be in, obviously. So now let's rewind. Let's go step by step. We had 6 main steps to this attack. And step by step, let's try and analyze how this attack could have been prevented or detected so that it could be mitigated early. Because most of these similar attacks, whether they are more sophisticated or less sophisticated, these financially motivated attacks are usually preventable. They are not something that there's nothing we can do about. This is a very different ballgame from being the target of a large espionage campaign by a nation state, which of course there's a lot we can do about that too, but that is potentially harder when they're leveraging 0 days and endless resources to target an organization. Here, this is, a monetarily motivated organization targeting these victims, and therefore there's a lot that can be done, even though no defense is perfect. Once enough is done, what's usually going to happen is if your organization is hard enough to target, they're just going to move on to the next guy because it's no longer a valid ROI. The return on investment is just not worth it. So that's why we want to focus on these specific things that could have been done at every stage to prevent this terrible stage from arising. So we'll start from the end and let's rewind step by step. So the last step, the fact that attackers here were actually performing the destruction, the damage to the environment, the actual encryption, even though this is, of course, a very late stage and we'd like to detect and prevent things before, even at this stage, there are things that we could look for in an environment. There are alerts and monitoring that we can put in place to detect that something's going on and hopefully be able to prevent at least some of it from happening. So in this case, attackers, as I said, they took the effort to remove or tamper with some of the backups and other policies that were in place to prevent this encryption from having such large impact. So that means that these steps are things we can monitor for. So if somebody deletes an active KMS key, meaning we're not going to be able to use that key to decrypt important data. If somebody suspends bucket versioning policies, so we will no longer have the previous versions of buckets, meaning we won't be able to recover back to them. If somebody deletes older versions of existing objects at a wide scale, so this is, again, to prevent recovery. These operations are not the encryption itself. Once the encryption happened, it's happened, of course. But these operations are usually not going to be standard operations in an environment, especially at a wide scale. And once they happen, we can and should have immediate response procedures within the SOC. We detected something like this. First of all, let's lock things down to make sure everything's okay. And then we can make sure that we are indeed in a secure state, or a more secure state than we would be if we let this go on. So this is the very last step, probably the simplest one, but also a valid point where we need to consider what we could have done to detect it. Taking one step earlier, the data exfiltration phase. Now, the data exfiltration phase, while more challenging in many cases in the cloud, is still a very doable and detectable phase of the attack. So if we see things like unusual mass get object actions on a single bucket, so we have buckets of information and somebody's now querying again and again and again and again for information from that bucket and something that's not regular for this environment's baseline. We can see similar things on multiple buckets rather than one with a lot of queries. We can see a lot of queries spread out across a lot of buckets from a single account or a single IP address. These things should, of course, trigger some alerts or somebody to have the opportunity to investigate further, in addition to, of course, specific services and their own visibility. So in this example, the key was RDS. RDS database was a key element of this client's sensitive customer data. And the fact that attackers were able to essentially go unnoticed while they were querying everything in the RDS, very wide, didn't even look for specific tables. This is something which could have been detected earlier. So if this would have been detected, A, maybe some of the data could have been stopped from leaving the premises because we're seeing it happening live and we can stop it. But B, the next step of the attack could have been stopped completely because an investigation would have already been ongoing and the malicious access could have been remediated. So data exfiltration phase, even in the cloud, even though this is very different from standard methodologies for detecting data exfiltration, like looking at firewall volumes, which may not be in place in the cloud or managed very differently, we still have a lot of very good information we could use to detect or prevent this kind of activity. Now, taking another step back, and this is really a crucial step, which is very complicated and difficult for these environments, this is this cross-cloud lateral movement. So if you recall, we discussed the fact that attackers came in through Azure, which had federated access to AWS, and leveraged that access to compromise the sensitive AWS environment. Now, there are many different ways attackers could do this, but I did want to mention two specific strategies for detecting this kind of behavior, which we've seen working in the past with a lot of our customers. So the first has to do with users being added to administrator groups. So once attackers get in to the AWS environment in this case, but of course it could be any cloud environment, they will often try to escalate privileges in a different way. And if they're already performing this access through something like federated access or a temporary token, they're going to want to consolidate their access because they may not have that initial access point forever. So they're often going to add or modify users so that they have more access, more privileged access at an early phase as a way of establishing persistence. This is obviously something which we could have alerting for. This shouldn't be going on every day, all the time in an environment. Nobody's modifying the most privileged admin users every single day. And if they are, maybe we need some new procedures, but at least the SOC can monitor this and detect potentially suspicious behavior. Number two is a very interesting example that we saw here, which is users adding themselves. So I'm not going to get into every possible technical way that this could be done, but we've seen many cases in which privilege escalation by different users is accomplished through this. So users which can assume a more privileged role, for example, use that role to add their own user, the user that was initially compromised, to an administrator's group. Now, this thing is, again, potentially done for persistence because once somebody already has the access, why would they add themselves? The reason is for this, so that if they lose the access they currently have or the role they're currently assuming, they can keep operating as a different user or a new user that they've created without being impeded. So these kinds of operations are specifically interesting because they're A, pretty common in these attacks. We're seeing them more and more, and B, not very common in standard environment operations. And this is a key combination because it means they are detectable and therefore we can prevent the remainder of the attack from happening. So this is just a phase that I wanted to focus on, but if we keep moving backwards now to the Azure environment, so remember we mentioned the attacker here was able to escalate privileges rather easily thanks to misconfigured privileges for an application user which was initially compromised. Now, again, there are many different ways to approach this, but I want to mention two more ways that we think it's very interesting to detect this kind of potential behavior. The first is pretty obvious when global administrator role is added to new users. So attackers approach this in different ways, but if they indeed have a new user that they create to establish persistence, and then that user is granted high privileges, that's something which could be very detectable. And even if we get false positives on something like this, let's say a real new global administrator has been created in an environment, that's still something which should be pretty easy for the SOC to validate. They see an alert, they pick up the phone to whoever is responsible for that user, they ask, was this you? If the answer is yes, case closed. But if the answer is no, they know to take it very seriously and they can mitigate the rest of the attack. Second is very privileged operations being performed for the first time by a user. So this kind of detection is more difficult to implement. This requires tailored baselining per user or role or account in a cloud environment. But this kind of detection is also very effective. So if there are specific users who always perform only one kind of operations and suddenly they're doing something else, even if they have the privileges, it's the first time they're doing it, these kinds of operations can and should be alerted for the SOC. Now, the SOC can then take different steps to validate whether or not this is a false positive, but the fact that they get this alert is going to enable them to identify a lot of malicious activity. And also it's going to enable them to continuously improve these baselines. So a lot of what we do for our customers when we have our TTPs that we build for them is we continuously improve these baselines, because that's the only way to get to an accurate, very effective TTP that we can detect for malicious activity. So this is for privilege escalation. With that, I want to move back one more step to the initial access. So again, many ways to detect potential initial access to a cloud environment through a compromised access key. But I want to touch on two things here. The first is sign-ins or logins from irregular IP addresses. Now, the very basic of this is something that most security tools do by default. You know, if you have suddenly a login from a country that nobody works from or something like that, you're usually going to get an alert. But that's not exactly what I'm referring to here. Because if you recall, what attackers did in this attack, they were clever. They went from their own IP to a VPN to another compromised Azure environment, and only from there to the client environment. So looking for a rare country or something like that wouldn't help here, because the source IP address for the malicious connection was another Azure IP address. However, if an organization ensures to have detections which look for specific tailored deviations per user or per entity logging in to the environment, then even legitimate looking IP addresses can be identified as out of the ordinary. So in this case, the application that was used, that was compromised, and its credentials were used to access Azure, that application was actually not running in Azure itself. So that means that if the organization would have been monitoring specifically with a tailored baseline where logins with this credential are coming from, they would have seen, wait a minute, why is an Azure IP address logging in with this credential? That's not right. Let's look into it. And they could have prevented everything that came later at a very early stage by detecting this initial access. So that's something that we definitely recommend and works for detecting a lot of these attacks at a very early stage. Now, second is specific unusual activities from these IP addresses. So even if we're not referring to the login, like we mentioned before, new activities being performed from a specific IP address, something that's we've never seen before, that again could be an indication that something's wrong. So even known IP addresses like Azure IP addresses or AWS IP addresses, if they start performing activities that they specifically never perform from these addresses, again, this is something which through tailoring detections, we can get the SOC to a place where there aren't too many false positives, but it is a very valuable detection. And this is something we work with a lot of our customers on. Now, finally, we get back to the very first step of this attack, which is the reconnaissance. Remember, attackers were scanning. They were able to fully clone GitHub repositories, which included some credentials. Now, of course, scanning, especially of repos that are by design public, that's going to happen. There's not much that we can do about that. But what we have seen with some of our clients is that we can create specific detections and alerts for this kind of behavior so that the SOC is aware of what's going on. So looking for full clones of public repositories it depends, of course, on your specific environment, but in many environments, even if repos are public, they don't get fully cloned all the time. And if they do, it's very often by scanners. So noticing that something like this happens doesn't mean we block everything or assume the worst, because maybe that's legitimate, or maybe that's just part of doing business. We don't care. It's public. But when the SOC is aware of this, they could be a lot more vigilant in monitoring what's going on within those repositories and taking the necessary steps to remediate attacks if they do originate from there. Number two, and this has to do more with monitoring employee behavior than attacker behavior, but if you recall, what we had here was an employee operating in good faith. They accidentally uploaded credentials, and then they right away realized what they did and deleted those credentials. Now, the employee didn't realize, A, that this repository was being scanned, and B, the problem with GitHub history, which could still contain the credential, even if the current version doesn't. However, this is something the security team should and will be aware of. And that means if the security team has specific alerting for this kind of behavior, which is not malicious behavior, this is just behavior by an employee indicating that something may be wrong. So code being uploaded and immediately deleted is just one example here that we've seen with a few organizations is relatively rare, and therefore can be created as an effective alert. This could enable the SOC to find out that something is out of the ordinary, and based on that, to go ahead and remediate the attack, or at least figure out that the credentials need to be rotated. So again, the point of going back through all of these phases isn't to say that these are the only potential phases of these attacks, or that these are the only potential detections for remediating the attack. Not at all. This is a wider area. But the key point that I would like to convey here is that much of this attack was in fact preventable. So at every stage, we raised some ideas here for things that are either not very complicated or moderately complicated to implement. And the key for them is implementing them based on tailored baselines, being able to use these baselines to identify what's truly going on within an organization. And that, if we look at our chart here, essentially at every step, we said, if this would have been in place, none of the rest of the attack would have happened. So we're not saying any step here is completely dispositive of everything else, but rather the approach of defense in depth that we're used to from on-prem environments makes a lot of sense in the cloud too. It may not be as linear, but having multiple layers of defenses and detections can enable the prevention of a lot of these attacks, and that is very, very valuable. Now, I want to end here with a few key takeaways for how to approach these kinds of environments and how to defend them. So first, if the cloud-specific attacks require cloud-specific defenses. Now, this may sound like stating the obvious, but unfortunately, what we're seeing with a lot of organizations is that, especially organizations that are still making the move to the cloud or have hybrid on-prem and cloud environments, they essentially just copy-paste whatever defenses they had for their on-prem environments, their alerting, their security tools, their SOC operations, and they just say, yeah, this is going to apply for the cloud as well. And while the cloud isn't inherently more secure or less secure than an on-prem environment, it is different. And it contains different attack surfaces and different opportunities for attackers. It also contains a lot of different opportunities for defenders. You may have much better logging in the cloud. You may have an easier time quarantining or taking down resources in the cloud. But that means that unless we, as defenders, tailor what we're doing to the cloud, we're just giving over this advantage to the attackers. And that's a big downside for which we have to be prepared. So that's number one. Number two is speed is crucial to incident response in the cloud. Speed is always crucial to incident response. But as we've seen in this example, in the cloud, because of the intersimilarity of many cloud environments, and because of the always online nature of these cloud environments, attackers are leveraging automation to a much greater extent than they were and still are in on-prem environment attacks. The initial compromise, a lot of the reconnaissance that they perform, because these environments all have the same things, the same configurations, they can leverage this automation and move very, very quickly. This means that if incident response doesn't move as quickly, it's just going to lose out. It's not going to respond in time. And a key example for this would be if incident response is still based on, we've seen an alert, now we go and investigate it, and then we figure out what to do manually. Attackers aren't doing that. They have playbooks. They have automated playbooks in many cases. So why shouldn't we, as defenders in our SOCs, have the same thing? Let's say we identified a user as potentially compromised. We should already have a playbook, potentially an automated playbook, for exactly how we quarantine a machine or how we prevent access from a certain user or role. We should be able to do these things in a very quick way, because otherwise even if we get everything right, we're just going to do it too late and attackers are going to win. So that's number 2. And then number 3, and finally here, is that centralized visibility is key to effective cloud detection and response. So this is something that we're seeing with more and more of our customers. The fact that they're able to get data from different cloud sources, whether it's different providers like Azure and AWS that we saw here, or whether it's other services as well. So you could throw in Okta as an identity provider. You could throw in some logs from an on-prem environment if you have a hybrid environment. Having this kind of visibility in one place and being able to create detections for anomalies that span more than environment, and in addition, being able to quickly look and understand what's going on across the entire estate, not just a single environment, is crucial. Organizations that don't have this often can't get the full picture. And as we saw in this attack, without understanding that the attack on AWS, for example, came through a compromised Azure environment. It was without understanding the compromised Azure environment came through a GitHub repository, which still had credentials. All of these understandings are crucial in order to fully remediate the attack, because without them, the defender really doesn't have a chance against a very well-trained and unfortunately very experienced attacker. So these are the key takeaways that I want to leave you with here. I'll just say one last thing, which is that preventing and fighting back against these attacks, we also have a lot of advantages in the cloud. And I mentioned some of them before, but really leveraging the speed, leveraging the automation, leveraging the fact that these cloud providers can often provide information in real time. We've worked with many of them, reaching out to them, getting more information that we don't have about our attacks. This is very useful for defenders. So it's not like we just have a pessimistic view here. We really do have a lot of benefits in the cloud. We just have to be prepared to use them the same way that attackers are using theirs. And with that, I'll hand it over to Phil. I think you're muted, Phil.
Thank you, Yotam. That was awesome. And we have some questions also in the chat. You can either handle it in the chat or we can also do it live at the end of my little segment here. So I want to talk about cloud detection and response, CDR. It is an acronym. It is something that Gartner has coined. There is an analogy to endpoint detection and response in the sense of having a purpose-built platform for detecting, responding, and containing specific types of threats, in this case, for the cloud. Let me just go into full screen mode. So, Yotam touched on some of these things, why everything changes in the cloud. And as he mentioned, it has benefits for both attackers and defenders. The use of automation to quickly execute attacks also applies to how defenders can quickly contain attacks and investigate them. The richness of cloud services, which gives attackers so many different pathways into the environment, creates many opportunities for attackers, but also very rich logging telemetry that is very easy to ingest. It's not like you have to set up forwarders and collectors and parsers. You can just connect a platform to these APIs, grab all of this data, and then analyze it. And then finally, the central control plane, which gives attackers an advantage in the sense of being able to programmatically discover resources, escalate privileges, and all the things we saw in this last attack, also allows us to monitor what's going on there and quickly take away that access. So in terms of the platform that we provide, and I apologize for the order here, GEM has built a purpose-built cloud detection and response platform that ingests telemetry from the top 3 cloud providers, AWS, Azure, and Google Cloud. And recently, we also announced support for monitoring of the top identity providers, Azure Active Directory, and Google Workspace. And of course, we also do Kubernetes. And so what the platform does is programmatically ingest many different types of logs from these platforms, including logs that would be impractical to put into a SIEM, like VPC flow logs and DNS logs, and then analyzes it using a variety of different detection techniques, including both out-of-the-box detection rules, as well as behavioral analytics that have been specifically designed for cloud entities and cloud behavior, and then generates alerts, which are typically sent to the SIM if it's a large organization that has a SIM, and that could be a Splunk, could be IBM QRadar, could be Azure Sentinel, Sumo Logic, others, as well as to ticketing systems. But to add additional context to the investigation phase, the system also ingests from other systems, such as from code repos and ticketing systems, and from other types of cloud security platforms like CSPM, Cloud Security Posture Management platforms, that are more focused on identifying vulnerabilities and misconfigurations. And that can also help provide additional context, because obviously if you see an unpatched instance or an unpatched bucket or a misconfigured bucket, and you see that it's being targeted by the attackers, that would be additional context to raise the severity of the threat. So I want to give you an example. I'm sorry about this. So the main functions that the platform provides to address the scale and complexity of the cloud are, number one, to make sure you're actually collecting the right logs from all the cloud accounts, services, and subscriptions across your infrastructure. So we call that preparedness, making sure you have the right logs so that if you do get breached, you have the information you need to investigate and contain the attack. Number two, the detections that we talked about, specifically around multi-step attacks. And given that there's so many new things going on in the cloud that are legitimate actions, how do you minimize the noise? And we use behavioral analytics to look for unusual activity based on profiles of various entities like clouds and storage buckets and users. The ability to build attack timelines, so you could quickly decide, is this an important alert? Is this something I can ignore? Should I write an exclusion for? And then you can identify root cause. And then finally, contain the attacks. And Yotam mentioned some examples of how to contain an attack: isolating an instance, deleting access to an asset, taking a forensic snapshot. And all this is done in a platform that is agentless, so therefore very easy to deploy, that integrates with your existing SIM, SOAR, XDR, CSPM platforms, and that is not priced based on ingestion, uses a data lake architecture that makes it very practical and cost-effective to store large amounts of telemetry at relatively low cost compared to what it might be in a traditional SIM. And so just some examples of screenshots. This would be an investigation timeline. So this typically would take hours of effort by an analyst looking at various screens to be able to put together a timeline of what happened, perhaps starting with an alert. In this case, the initial alert is shown here in pink, the create user, but what the timeline shows is the important activities that happen before and after the alert. It also combines multiple activities together into a single activity to minimize the amount of events you need to look at. So this would be an example of a timeline. This would be the example of the blast radius map, which isn't a typical map showing potential paths for attack. It actually shows the actual paths that the adversary took, so you can quickly understand in a visual way what the attack looks like and identify root cause. And then additional context, in this case, showing for a given entity, or let's say a user, what are all the different services that this user was accessing before and after the alert fired. So not only you see here also the richness of services that can be monitored by our platform, but also how you can get additional context about, is this unusual or is this something that happens on a regular basis, to help you further triage the alerts. Now you might be asking, I've heard about lots of different cloud security tools. Where does cloud detection and response fit in the sort of portfolio of various security tools I would need? And most of the early cloud security tools were focused on CSPM, which is Cloud Security Posture Management. That would be static configuration scanning, similar, for example, to a Tenable in a traditional environment, and also workload-focused tools that look for vulnerabilities in actual workloads as they're running. I would describe these as left of boom. And if you look at the NIST model of the various pillars, it's more in the identify and protect side of those pillars, whereas cloud detection response is in the middle here, real-time detection response and containing of an attack, where normally you might have used SIM tools for doing it, but we find that SIM tools really weren't designed for the complexity and the scale of the cloud, although certainly integrating with your SIM as the central point in the SOC is typically what our customers do. In terms of industry validation for our platform, we're now securing cloud operations for dozens of organizations in all kinds of verticals: financial services, hospitality, software and technology, manufacturing, energy, as well as having been recognized recently by Gartner as a cool vendor for the Modern Security Operations Center. And then our investors include some notable investors, including Cisco and IBM, as well as Silicon Valley Cisco Investments, which is a group of CISOs and former CISOs that act as angel investors, Teammate, which is a very well-known global investment firm, and GGV Capital as well. To learn more about our GEM and our CDR platform, I've included some links here. The links are live in the version that you're going to receive from SANS. We recently did a blog and a live webinar that Yotam did earlier this week, last week on the Okta breach, earlier this week, excuse me, which was an interesting breach because if you ask yourself, how would I protect myself against a breach that was executed through stolen credentials, you can see it doesn't matter how good your security hygiene is. If someone steals a valid credential and gets into your environment, you need a different way to figure out how to protect yourself against that type of attack. And Yotam reviewed what we know about the Okta breach and how to protect yourself in the future. We also have an upcoming webinar with the Black Hat community, practical lessons from a Fortune 500 security leader on multi-cloud detection and incident response. This is an actual GEM customer from a financial services company that's going to talk about their approach to dealing with detection and response for the cloud. And then I've included some other assets here to get more information. And I'll hand it over to Yotam. Yotam, I don't know if you want to go through some of the questions that came through in the chat or others that you think would be important to talk about. Go ahead.
Yeah, definitely. So I answered a couple in the chat, but I do want to refer to another. I think it would be valuable for everybody, and that's the question of hybrid on-prem and cloud environments. So there was a specific question about some of these detections in those kinds of environments, and that does present a relatively unique challenge, especially because we're seeing attackers now going back and forth. So some attacks start on-prem and move to the cloud. Other attacks start in the cloud and move on-prem, which is the rarer but unfortunately rising form of this attack. And in a hybrid environment like this, the key challenge, even more than in a multi-cloud environment, is consolidating the data sources. So if there isn't a centralized location which enables effective detection and effective analysis of what you can and can't see, it's very difficult to do this. Now, as Phil was just mentioning, a SIM is often a crucial first step in this because you need a centralized place where you can forward your logs, especially from an on-prem environment, but it very often won't be enough to cover the needs of the cloud environment just because of the sheer amount of data. So because there's so much potential logging in the cloud, then you're forced into this choice of either not forwarding everything you need, and then you're going to miss stuff, or forwarding too much, and then your bills are going to go to the sky. And frankly, in many cases, you're just not going to be able to query the SIM because there's going to be way too much data. You're going to wait 10 minutes for a query to work, and nobody can operate that way. So the key that we've seen as effective to solving this problem is having a well-maintained SIM that contains the key logs, especially from the on-prem environment, together with having an effective solution like a CDR, which enables you to see in one place everything that's going on across the different cloud environments, what visibility you do and don't have. In addition to that, what potential malicious activities have occurred, and to effectively, quickly triage what's going on. So it's not enough to just get an alert and here's a pool of data in your SIM or somewhere else and good luck. You actually want to have something which provides you with all the relevant events, some sort of timeline of what's going on before, after, the key elements of what potentially went wrong. And that way you can effectively respond, ideally even prevent the malicious activity from happening. So that's to the question of the hybrid environments. I will just make one more comment here, which is in these cloud environments, especially the very large ones, there is also, unfortunately, a very common trend of shadow IT. So this existed on-prem as well, but it's much easier to do in the cloud. You know, different departments in the organization, they just have their privileges. They click a button, they get 100 new servers spun up, they get some serverless code running, they get new buckets, and then it's very hard for the security team to monitor everything that's going on because they may not even be aware of it. They may find out that there's a brand new AWS or GCP or Azure account being used by some department they were never told about. So this is, of course, a huge problem, because even if you have the best security tools and the best security people, if they don't know about what they should be monitoring and protecting, they're not going to be able to do it well. And this problem has been magnified dramatically in the cloud. And the way to approach it, of course, is not just to say, okay, let's not let anybody operate this way anymore, because we want this flexibility that the cloud provides these different teams, but instead to have this freedom within very set boundaries. So instead of creating new accounts or stuff like that, let's create the right kind of roles, the right kind of initial infrastructure with the security team. So IT and security have to work together from the start to have security by design, so that this flexibility occurs and new infrastructure, new needs are met potentially individually by the different teams, but within an environment that already has policies enforced by the security team, so they're never going to miss anything. And unless this is done, it's going to be very difficult, even with all these other solutions, for SOCs to really prevent these attacks.
Very cool. Do you want to go over any of the questions that you answered in the chat? For example, the one about are these Azure logs standard? I know there's been some discussion about this in the last few months, because in an attack a few months ago by a nation state that actually got through to some of our government accounts, there was an issue with logs not being captured. But I believe those were Office 365 logs. Do you want to talk about the logs you talked about today, please?
Sure. Yeah. So I'm not going to go into every kind of log. First of all, I don't know them all by heart, and also that could take a while. But I will say specifically that the services differ. But specifically for Azure and Office 365, this is an interesting balance, because people often pay for it together. They have a Microsoft account the way they look at it, but the logging could be different. Especially for Office 365 logging, the different tiers that Microsoft has, the 3, the 5, 7, all these things provide different levels of visibility. I think the key is not just to say, okay, we always have to have the top tier for everything, and that's the way to approach the problem, because first of all, of course, it's expensive, but even if you can't afford it, there is an issue with having too much information. We mentioned this in the cloud. Drowning in noise is easy for a SOC, and getting rid of the noise is hard. So what we often do with our customers here is we just tailor it to their environment. So based on the activity they have, based on the critical resources they have, then you have to figure out which logs are crucial and which aren't. For what we discussed today, a lot of this information, like the logins, like the potential modification of user credentials in AWS and in Azure, a lot of this is standard. It's logs that you have. You just need to know how to use them right. Some of the more detailed analysis, especially if you want to do RDS logging or specific access to S3 buckets, things like this, these are not going to be default or free. But whether or not you require them and to what level really depends on the specific environment. So that's why tailoring it with the security team, not just having some budgetary restriction thrown on them and then they have to operate within it, but actually having the security team within this process is key to making sure that the right kind of logs, not necessarily all the logs, but the right logs are being collected.
Thanks, Yotam. And with that, we'll wrap it up because I know you're a big fan of making webinars shorter rather than longer. So thank you, Yotam. Thank you to SANS, and thanks to the SANS community for participating in today's webinar. Look forward to many more from Jem and from Yotam, and have a great rest of your day. Thank you very much.
Thank you, everybody.
Thank you so much, Phil and Yotam, for your great presentation, and to Gem Security for sponsoring this webcast, which helps bring this content to the SANS community. To our audience, we greatly appreciate you listening in. For a schedule of all upcoming and archived SANS webcasts, including this one, please visit sans.org/webcasts. Until next time, take care, and we hope to have you back again for the next SANS webcast.